Hello everybody. Today has been a long day and I have been wanting to get this video out for quite a while. So this is a little later than I wanted it to be, but better late than never. And from the looks of the grade book on my math lab, I'm still getting this out in plenty of time for you to work on the assignment. But anyway, I want to make this video partially to do a little reviewing and then to tie that in to the last concept I need to mention for this series of videos. Okay, my ultimate goal is to do a problem like this one. So here I have our assignment open, and this is question 10. Is on your assignment, it's going to be something like this, but it gives a certain function, so on, describes a little bit about it, gives the units for the numbers, and then the question is to give the point of diminishing returns. Now, that's not hard to do, at least in the big picture, all right? It's not that hard to do. I can tell you in less than 30 seconds how to do it. Here's how you do it. You find the second derivative of this, and you set it equal to 0. And that's it, okay? So it's not hard for me to tell you how to do this problem. But I think I'm obligated to do a little more than that, and I think along those lines there's I think a misconception in math about that math is just calculating and math is just technical skill, and that's it. It's nothing more than that, and that's not really true. I mean, math does involve some technical skill, and obviously it involves some calculating, but it also involves understanding a lot of ideas too. And I actually think for anybody taking this class, for whatever you end up doing, it's probably the ideas that are just as important, maybe even more important, as the technical skill, okay? I don't think very many people who take this class end up doing something on a day-to-day basis that involves a lot of technical skill in terms of solving an equation or applying complicated symbolic rules like to find derivatives or something like that. I think most likely you're going to be dealing with the ideas behind all that. All right, so I could be wrong about that. I don't know what any one of you is going to end up doing, but I think that that's a very safe bet for me to say that. So yeah, there are a lot of ideas in math, and I think that the ideas for most of you are probably more important, if not as important. You know, it's hard to say, but at least as important as the technical skill that we get along the way. So in the book, there's a lot of words to read, okay? So notice this, there's this discussion, and you can get this textbook. Every problem in my math lab is linked to it. All you have to do is go to have any problem that's open in my math lab, and then if you go to get more help, textbook is one of the options. So you can look at the relevant part of the textbook that way. But there are a lot of words here, okay? It's not just numbers, it's not just equations, there are descriptions and so on. So yeah, that's the ideas part that I was talking about, okay? And there are, I think it's worth looking at the textbook. There's a lot of neat pictures, some of which I'm going to discuss in my own form. Like I've been talking about curves and the slopes of curves almost all semester. So that here's a curve, it's concave up. The slope goes from negative to 0 to positive. It's increasing. And here the slope is positive everywhere, but it's getting steeper. It's increasing. These are both concave up. And then there's a lot of words to go along with this. So I'm going to encourage you to read it, all right, and think about the ideas, and to consider, you know, what may seem to be like overly complicated things I tell you in the videos. So I tell you that because I think the ideas are probably more important for you in the long run. Okay, so that's my kind of story to start this one off. Now, with that being said, don't say or don't think that I didn't tell you the simple way to do this. I know that not everybody's interested in the ideas. I know that there are plenty of students that just want the simplest way to solve this and they don't want to think any more about it. And I already told you that. You find the second derivative and you set it equal to 0. Okay, you solve that equation. That's what you do. So, okay, now I said that, that's the disclaimer. Let's talk about this. So, part 1, I wanted to tie everything together. I want to give you 3 curves right here and tell you that, well, they all do look different, okay, but they have something in common. All three of these curves are concave up, okay? And that means that the derivative, which is the slope of the curve, is getting bigger from left to right. So here, this one's kind of like that one I just showed you in the book. Over here, the curve has a negative slope, then it goes to 0, then it goes to positive. So yeah, the slope's increasing from left to right. And then here, like, well, here this one is concave because it's getting steeper, okay? The derivative, the measurement for the slope, is still a number that's getting bigger as you go left to right. Now, but that's also true with this last one. And I included some numbers. These are just estimates, but you get the idea. Here it's got negative slope all throughout the curve. Here it's steeper and negative, and it's getting less and less steep in a negative direction. You might say, with some reasonable estimates, that the slope is -2 at this point, and it's -1 at that one, and then it's -1/4 at that one. Those numbers are getting bigger as you go from left to right. -1 is bigger than -2. -1/4 is bigger than -1. So even though all these look different, they're all concave up. The derivative is increasing from left to right, and the second derivative is positive. Those are three equivalent statements. You can think of them as the same thing. Concave up means that the second derivative is positive. It also means the slope's increasing from left to right. Okay, so don't think of concave up as just being this obvious bowl or U shape. I mean, it could be this one or it could be that one. It just means that the slope is increasing from left to right. Okay, now it might be, now here I did not discuss concave down. All right, I didn't mention it. Concave down would just be the opposite of this, that the derivative is decreasing from left to right, or the second derivative is negative. All right, now it might be though that any given curve has one region where it's concave up and then another region where it's concave down, and then those two regions have to be connected by a point that's neither, where the transition between being concave up and concave down happens. Okay, so that point is called the inflection point. All right, inflection point is just the point where a curve transitions between being concave up and down. All right, doesn't have to be up to down, it can be down to up. It's just the point where the transition happens. Now, as far as the numbers go, concave up means the second derivative is positive. Concave down means the second derivative is negative. And the inflection point, where the transition between those regions happen, is where the second derivative is 0. Okay, now those are just some basic facts. Now, I want to talk about part 2 of this, okay, because originally I told you I wanted to solve this problem about finding the point of diminishing returns. I didn't really give you any context for this problem. I just said that's what I wanted to do. So part 2, let's talk about the relevance of all this to diminishing returns and what diminishing returns are. Now I want to give you a simple model. Okay, suppose that we're able to model either by collecting data or surveying or whatever. We say we can get these numbers for some company where we can track the revenue versus the dollars spent on advertising. So it may be like we have some historical data at $5, and I'm keeping the numbers really simple here. I know that it might be funny to think of $5 spent on advertising and $20 in revenue, but let's keep the numbers simple just so we can get the ideas. So suppose that we've got this historical data and say, well, when we spent $5 on advertising, we got $20 in revenue. And when we spent $6 in advertising, we got $27 in revenue. And when we spent $7 in advertising, we got $35 in revenue. So let's say that maybe that's how the numbers work out. We'll just have to accept it for now. I want to give you these observations about those numbers. I see that like one pattern among these numbers is that the more you spend on advertising, the more you earn in revenue, right? 5, 6, 7, 20, 27, 35. Okay. But I guess the main observation that's relevant to this lesson and what we do in this class is a little deeper than that. We want to notice that, well, look, between $5 and $6, the extra dollar you spend on revenue gets you $7 additional dollars in, or sorry, take that back. The extra dollar you spend in advertising gets you $7 additional dollars in revenue. So I want to think about it in these ways. If I'm wherever I am, if I spend the extra dollar, how much is that going to increase the overall situation? Okay? So spend the extra dollar here, get $7 more in revenue. That is actually the slope of this curve. If these numbers had a curve or a graph, what I'm talking about would be the slope, the rise and the run. Increase the x by 1, increase the r by 7, okay? But yeah, so I spend the extra dollar here between 5 and 6, I get $7 additional in revenue. But then if I spend the extra dollar between 6 and 7, I get $8 additional in revenue. So I see that, yeah, the more you spend on advertising, the more you'll earn in revenue. But it's not like it's in a consistent way, right? So here, yeah, spending the extra dollar gets you 7, but here in this other spot, spending the extra dollar gets you 8. And why is that? The answer to that might be a complicated question with many factors contributing to its answer. But for us, we're just seeing that, yeah, the earning the additional revenue happens in different ways. Okay. All right. Now that's just an idea. That's just a concept and something in our heads that we use to put together this whole picture. Now, how this might tie into the whole picture is that if that was the nature of the revenue curve, then the slope of that curve would be increasing. The extra dollar is seen to get you greater and greater amounts of additional revenue, and it would be concave up. Okay. All right. Now let's take this a little further. What if the revenue model looked like this? So here I'm imagining it not as a table of numbers, but as a graph. But they're really the same thing in the end. If you took the table of numbers and you plotted all of them, and you drew the picture of the pattern they made, that's what the graph is anyway. So here I'd say, well, suppose it looks like this. And again, I just want you to suppose that. All right. Then if the curve is like this and it's getting steeper from left to right, that would be called concave up. But it would be true that for the curve to have that shape, each extra dollar spent yields additional revenue, but in increasing amounts. That's like this. Yeah, the extra dollar spent is getting me more revenue, but the amount more is getting bigger itself, okay? So yes, that's what I'm looking at here. Now, then if the curve transitions to this shape where the slope is decreasing, then the story would be that each extra dollar spent yields additional revenue. It still gets you additional revenue, but in decreasing amounts. So see how the revenue is increasing through the whole curve? But at some point, that extra dollar I spend, it may get me more revenue. It may keep getting me more revenue, but the amount by which it's growing is getting smaller. So it's still growing, but the little growths are getting smaller. Now that is called diminishing returns. We're still getting returns, but the returns are getting smaller. So here, the returns are getting bigger, and then at some point that changes. That's called the inflection point, and the returns start getting smaller. Now in economics, as most people who are in this class have to take several economics courses, there is a law of diminishing returns that is related to this, okay? So yes, all right, it happens, and you probably, maybe I'll offer this as an exercise to you. Try to think about, are there areas in your life where like you put the extra effort in, and yes, you do get something for it, but each little bit of additional effort you put in gets you an amount of benefit that keeps, it's just getting smaller and gradually shrinking, That would be diminishing returns, okay? There are probably lots of scenarios you can think about that are like that. Okay, now that's what that question was asking us for, is where's that point where the extra dollar, starts getting you additional revenue in decreasing amounts? So that'd be like an important point on a curve. It's where everything changes, okay? All right, now, so that's what a lot of this discussion in the book is related to. And like I said, I might encourage you to read the book. It's probably not for everybody, but if you wanted to read something more, help the ideas sink in a little better, it's something I can recommend. Now, let's solve an example like that one I showed you at the beginning of the video. Okay, so here's an equation that provides a model for revenue versus dollars spent on advertising, just like I was talking about. That equation is negative x to the third power plus 33x squared plus 1100. It applies for x being from 0 to 16. Say that's given to us, okay? And that's not something we can argue for. We might wonder how somebody could come up with such a model, but for the sake of this problem, it's given. Now, the question is, find the point of diminishing returns. Now, that's just the inflection point. All you do is find the second derivative and you set it equal to 0 and you solve it. Remember, I started the video, I said, if all you want is the answer, that's the answer. Okay, now when I solve this, I say, well, I take r of x, I need the second derivative. So to find the second derivative, you got to find the first derivative. Okay, so that's r prime for negative x to the third power. The derivative of that element of the equation is negative 3x squared. For 33x squared, the derivative of that element of the equation is 66x. And then for 1100, being that that's just a constant, the derivative of that is 0. So r prime is negative 3x squared plus 66x. Okay, and then I want the second derivative. So r double prime, the derivative of the first derivative, well, okay, so for negative 3x squared, the derivative of that element of this equation is negative 6x, and then for 66x, the derivative of that element of the equation is 66. Okay. Now, if you need to review the rules for derivatives, we can look back at the earlier videos, or you can ask me directly for help. But that's what we get for r prime and r double prime. From here, I would just need to solve that for 0. R double prime of x equals 0. That's very simple equation this time. Negative 6x plus 66 equals 0, whose answer is just 11. Okay, so that's the whole key to the point of diminishing returns. Now, I guess the point, technically that word means x and y. It's a point on a graph. It's got an x coordinate and a y coordinate. And what the solution to this gave me was the x coordinate. Okay, so there's this point on the revenue curve. Its x coordinate's 11, and that's where the transition happens between increasing returns and diminishing returns. Okay? All right, so let's do this. If we wanted the point, the complete number, the x and y coordinate, solving for 11 gets me the x coordinate. How would I get the y coordinate? Well, this is the revenue curve, from this, okay? So if I put 11 into this initial equation that is the function and curve we're talking about, that would get me the y coordinate, which is 3,762. Okay, so that's the point of diminishing returns, and I could give you my final answer, make it official, 3762, put it in a box, and that's what would go into the answer box on my math lab. Okay, so there's a even bigger story behind this than I told you, if you thought that this was a long video. And I hope maybe if you're taking economics or you have taken it, you can think back on the law of diminishing returns that you learn about there and think about the relevance to this. You could look at the textbook. That's another thing you could do, right? And then one last thing that you can always do, it's always an option, is to ask me for help.